Hello guys, welcome to Lead Electrical Academy. In this class we will discuss the three-phase full converter fed with separately excited motor. So in the three-phase full converter separately excited motor, T1, T2, T3 are taken and these are having a T1, T2, T5 are taken and T4, T6 and T2 are the negative group. T1, T2, T5 are the upper group and T2, T4, T6 are the negative group of lower elements, which is connected to three phases A, B, C, and which is connected to load voltage and having a armature resistance RA and armature inductance LE, which is connected to motor which is having a back EMF of EB, and field is separately connected. For this, it is shows a three-phase fully controlled RE load, as the load is supplied by the three-phase supply A, B, C. So the three-phase full converter is preferred for regeneration where regeneration is required. Where regeneration is required. Regeneration is required. So the number is given according to the sequence of thyristor to be triggered. So when alpha equal to 0, T1 is triggered. When alpha equal to 0, T1 will be triggered, as the most positive voltage appears at 30 degrees. So it appears at 30 degrees. And the T2 is triggered at most negative voltage, that is 90 degrees. So the T2 is triggered at 90 degrees. And similarly other thyristors T3, T4, T5 and T6 are triggered at T3, T4, T5 and T6 are triggered at 150, 210, 270 and 330 degrees respectively. So these are the triggering angles. So it is observed that thyristors are commutated at every 60 degrees. So they are commutated at every 60 degrees. They are commutated means turned off at every 60 degrees. They are commutated at every 60 degrees. Every 60 degrees it will be commutated. Alternatively, upper and lower group of SCRs. So this is upper group and this is lower group. Lower group. So each SCR will conduct for 120 degrees at any time. Every thyristor will conduct for 120 degrees. Thyristor conducts for 120 degrees. Every thyristor will conduct for 120 degrees. And two thyristors, one from positive and other from negative, must conduct together for the source to energize. So first one thyristor from positive element and one thyristor from negative element should conduct for energizing the load. So for a phase sequence of ABC of three-phase supply system, the thyristor pairs T1, T2, first T1, T2 will conduct, next T2, T3 will conduct, next T3 and T4 will conduct. So these are the conductions. So here alpha equal to 45 degrees he has taken. For alpha equal to 45 degrees, the conduction sequence is from T1 to T6 no. So T1 is triggered at 30 plus 45. 30 plus 45 means it is of 75 degrees. So T1 is conducted at 75 degrees and T2 will conduct at 90 plus 45. 90 plus 45. So it will conduct at 135 degrees. So T1 will conduct at 75 degrees and T2 will conduct at 135 degrees. So in the similarly, then it is T1 is triggered and reverse biases, the T5 will be turned off and T2 will conduct. And here T6 is connected to B. So here the voltage appears across the load. So it varies from 1.5 phase. Here is given that 1.5 V phase maximum voltage. So 1.5 V maximum. This is the maximum voltage of phase voltage. VPM is the maximum phase voltage which is appearing across the voltage. So when T1 is turned on, T6 is commutated from negative group and T1 is already conducting. So the T1, T2 will conduct. So A and C across A and C T1 and T2 will conduct, and it is of triggered of 1.5 V phase M to Vm 0. So the sequence of triggering is of same thyristor levels, first VCA, next VAB and VAC, VBC, VCA and VAB. This will continue. When alpha equal to 90 degrees, the load voltage is symmetrical about the reference line. So at 90 degrees it is of symmetrical of the reference line. The average value is 0. So for alpha equal to 150 degrees, the T1 is triggered at omega t equal to minus 120 degrees. So it is of minus 120 degrees, it is triggered at alpha equal to, when alpha equal to 150 degrees, T1 is triggered at omega t equal to minus 120, and T2 is triggered at 270. T2 is triggered at 270. So these are the triggering angles or the output waveforms, and this is called the output of the average voltage is reversed in the polarity. So which means that DC source is delivering power to AC source. Here DC source is delivering power to AC source. So it can be called as line commutated inverter. Line commutated inverter for 3-phase full converter bridge. So it can also be said that converter delivering power from DC source to AC source, and 90 to 180 it work as a line commutated inverter. So both converter and inverter remains in fixed output voltage for alpha greater than 30 degrees. So here if you observe that as it is a 3-phase, V0 average output voltage is 3 by pi. It is conducting from 30 plus alpha to 150 plus alpha, and the voltage is from VA minus VB d omega t. So the value will be 3 root 6 Vs by pi cos alpha, or I can also write 3 root 6 by 2 Vm by pi cos alpha, or I can also write 3 root 3 by pi Vm cos alpha. So these are the output voltage equations. If we substitute these voltage equations in the separately excited DC motor equation, as you know, the speed equation V by Ka pi minus Ra by Ka pi whole square into T. In the place of Va, we can substitute this output voltage waveform. So here the large DC motors, the current used at no load, the motor current at used no load, motoring is not small. So the 3-phase converter is used in motor likely to be continuous. Even at no load continuation also we are considering as continuous. And we will see the output voltage and firing angle curves and speed torque characteristics. As you know, if we substitute the 3-phase value, V0 equal to 3 root 6, V0 equal to 3 root 6 by pi Vs cos alpha, 3 root 6 by pi Vs cos alpha. If we substitute this value at 0, the value will be maximum, it will be 3 root 6 by pi. At 90 degrees it is the value will be 0, cos 90 value will be 0. At 180 degrees it will be minus 3 root 6, so it will be minus negative value. So this is the firing angle curve characteristics, and as it is a series separately excited motor, it is having a drooping straight line characteristics. So while changing the speed from 1500, 900, 400, while decreasing the speed, the firing angle also be decreased. So these are the speed torque characteristics of 3-phase full converter. It is the speed torque characteristics are similar to the single phase full converter characteristics. So thank you guys, we will meet in next class.